Hi everyone, this is Raju from Smart AI Technologies. In this video, we are going to see a project called Skin Cancer Detection using Deep Learning. So the base paper that we are selecting is this. This is a IEEE paper. We are going to take it as a base paper, but we are going to define our own methodologies which are better than the existing system. So our model will be giving better accuracies and less loss than this paper. So first we will discuss in depth what this paper is mentioning. Then we will try to understand what we are going to do differently so that we are going to get better accuracies. You can see any models that we built, accuracies will be not better. So one of the model I am showing you now, the training accuracy is around 99 and validation accuracy is around 89%. And some other models are there: DenseNet, EfficientNet, VGG16, VGG99, ResNet 50. Total 5 different deep learning models that we are using, and all of them are giving good results. Training accuracies are almost around 98, 99, and validation accuracies are ranging around 90, 91, 92, 89 for different models. So further we'll discuss about those things one by one. Before that, we are going to discuss about the paper, what is there in this paper, what methodology they used, what data set they used, and how much accuracy they are getting, and then we'll discuss what we are doing better than this paper. So we are getting more than 98%, 99% of accuracies. And yeah, the first part is abstract. In their abstract, they are mentioning like they are using ISIC dataset, which contains 2637 images. In our case also we are going with ISIC dataset, which are having 9 classes, and that each classes will be having several number of images. That proposed methodology by this paper is giving around 88% of the training accuracy. But one more thing is here, this paper is discussing about only benign and malignant, two kind of cancers, but in our case we are going to discuss about 9 different classes of the cancers. This is that ISIC dataset. You can see here under train and test there are 9 different classes of the dataset: actinic keratosis, basal carcinoma, dermatofibroma, melanoma, nevus, and benign keratosis, seborrheic keratosis, squamous, and vascular lesion. So there are 9 different type of skin cancers available in our case. So in our case we are using 9 classes, which is little bit better, and it will become much complicated than this dataset, because when number of classes will increase, when the number of subfolders will increase in your dataset, the time taken for training, the number of images will automatically increase. That leads to lot of complication. You need to train your model better, you need to build your model better than the 2 class models. So we are having better data set and we are getting better accuracies, so we are having more number of images. So from this abstract itself we can say whatever the thing that we are proposing, that we are using is little bit complicated, and that complicated also we are able to get better accuracies. And then we are going to see from here convolutional neural network, which model they are defining. They are building custom model, custom deep learning model, layer by layer. They are trying to explain in this paper, they are trying to explain how and what is that layer, one by one layers they are trying to explain us. Here you can see they are mentioning here under network architecture, you can see what are the layers are there, how they are stacked, and all those things. But the problem with this is it is not giving good result. We call this type of modeling as a custom deep learning model. You are going to build your own layers one by one, one above one. So in our case we are going with a transfer learning model. What are they and how transfer learning model is always better than the custom CNN model. So we'll discuss that also. And how they implemented it. In the implementation also, again they are trying to mention what are the different layers they are using in the deep learning model. And yeah, it is completely explanation of their custom model layers, how they are stacked and which are the layers are there. Convolution 2D, max pool 2D, okay, flat and dense. So about the models they are explaining a theory, and of that mainly this table is what we need. It means they finally trained the model for 50 epochs. They got 0.84, it means 84.7% of accuracy. 100 84.55, 150 epoch 85.45, 200 epochs 86.97, 250 epoch 87.42, 300 epoch it is 82.12. So it is normal that with increasing epochs, there is a chance of getting a better validation accuracy. That is testing accuracy or validation accuracy will increase. And if you go and see in their results, they are mentioning it again that they are getting around 88% of accuracy, like that. Whatever they are presenting in this table, again they are mentioning it in the result and analysis part as a graphical presentation. These graphs, we also got these graphs. These graphs are nothing but x-axis will be epoch, y-axis will be the value. Maybe for loss it will be loss value, for accuracy it will be accuracy values for each epoch. Now this is the existing paper. So from the existing paper, what we are trying to find, there will be always be a gap, there will be a research gap in any paper that you take. So we need to now find out what is the research gap that is there in this paper, so that we can improve our work and we can get better accuracy. So what we did, what are the challenges this paper is giving to us? The first challenge is that they are not handling the imbalanced data set. So what is that and how important that part is, we'll discuss. I will go with a very simple example now. What is an data set imbalancing mean? For example, in this case, in that data set they are using, maybe benign is having a 2000 images, okay, malignant is having 500 images. Okay. In this case, there will be a high imbalance, because whatever generally if you take any data set here, this is the problem. That paper is not discussing about it. Any data set you take, there will always be a minimal problem with the balanced data sets. So how to handle it? How we can make sure this problem will be solved, and what is the need for solving this problem? Is this problem is so effective? When we solve this problem, is that going to give a better result to us? So how to decide that? So now what we are going to do is, for example, in our case, we are going to balance it with the help of augmentation technique. Okay, so now when we build any model without augmentation, we are getting our model highly underfit, okay, or overfit, what you say. So underfit and overfit is a problem when your validation accuracy will be very less, but your training accuracy will be very high. For example, my training accuracy will be 95, but validation accuracy will be 45. In that case, your model is underfitting. Your validation accuracy is very less, so it is underfitting. So that kind of problem will rise. So to overcome that kind of problem because of the imbalanced data set, we are going to do augmentation and we are going to solve that. So what we do in the augmentation, first of all, is that, for example, here there is a one melanoma. Okay, let us say this is benign, is having 2000. Now melanoma is having 500. So now one melanoma image I will take. Now what I will do is, I will increase the intensity of the image, and then I will tilt that inside image little bit to right rotation I will do, and then I'm going to zoom it little bit out. So when I do all those things, a new image will be generated. So like this, from 500 images, for each images we can generate few new images. So for 500 images, if you generate 4 new images for each image, you are going to get so many images, around 2000 or like that. So then this data set will be balanced. So then if you train the model, the problem of the underfit will be solved. So your training accuracy and the validation accuracy or test accuracy will be in good scenario. Mainly validation accuracy, we call accuracy nothing but the validation accuracy will be better, it will be improved. So in our case we did this, and then we didn't stop here in our case. So what we gone few steps forward, and we thought of when we balance the data set. In our case there are around 500 like that, the maximum number of images are for each class, but that was not sufficient for us. So for each image we generated around 2500 images. So we try to make the entire classes. We have 9 different classes and we made 2500 images for each one of them. So now each class is having around 2500 images among them. So we balanced it. That you can see now code. So here you see, this was the normal first, okay, where it was an imbalanced data set. Once we balance it, here you see, for each class we have generated 2500 images. Now generating 2500 images will be easy, but this will be huge data. How to handle it? So that we'll discuss next. And this was the gap. So the paper was not discussing about this problem, underfit and overfit, due to data imbalance. So that we are considering, and that is giving a lot of impact on our result. Okay. Now the next problem that is going to arise is that they are using custom CNN models. Custom CNN models, that paper is being used. So the paper discusses about custom CNN model where they stacked layer by layers, one by one, and they built a CNN model. So in our case, as I was explaining, we are going to transfer learning models. Now I thought the paper uses CNN, it means here there is a chance of improvement. Here there is a research gap. So we can fit our analysis here, and we can increase the accuracy by adding something new. So we thought of going to transfer learning models, and the reason behind the selection of the transfer learning. What is the reason we will discuss now. First we will understand what is the difference between the custom CNN model as well as transfer learning model. So I will go to one general example. Let us take, there are two candidates A and B. Now what we do is, one person A don't know anything about martial art, but whereas person B knows about karate. Person A don't know anything about martial art, person B knows about karate. Now what I will do, I will try to train both of them for Kung Fu. I will try to train them for Kung Fu. Only for 1 week, time restriction. So now what you will think, who will learn better in 1 week? I am not giving infinite time. I am giving limited time and limited resource. So in that case, we will learn better and faster. It will be obviously B. Maybe this person don't know about kung fu, but he knows about karate, which is exactly similar to kung fu, a martial art, another martial art, which also will be having a lot of motions and everything. Okay, so you will be good in some martial art techniques. Now what if we take B and we'll try to manipulate his techniques according to our requirement? Within a short time we can make this person lot better in the process. Whereas person B, we are not saying he will not learn better. The problem is that if you want to make him to learn better, you need to train him for long time. 1 week is not sufficient. That you can see even in the paper. This papers is presenting that only in front of you. Epoch nothing but how many times you are training. For example, there is a boy, if you are training him for an apple, what is apple and what is mango. So one time if you train epoch 1, so one time he didn't learn very well, second time you train about apple and mango, it will be epoch 2. So like that our models also, how many times we train with our images, that is epoch. So the number of times you need to train will increase, and each time the time duration taken will getting increased. For example, in our case I will show you how that impact. So here you see, for each epoch it will be taking some time for that 40 seconds, but it will sometime take lot and lot of time. Okay, so that time 40 epochs, or for 50 epochs, for each epoch it is taking 40 seconds. If you make it 100, the time taken will be double. Okay, and that will be go on increasing. But whereas for transfer learning, the same thing, that this paper done for 300 epoch, I got better result only for 50 epoch, and that each epoch is taking around 40 seconds, not more than that. So it means one is time reduced, we are getting better accuracies, faster and better and efficient results we are going to get if you follow the transfer learning methodology or models. And one more thing we improved in our project is that we gone with small size images. And why we gone with a small size? Small size, for example, normally people will go for more than 200 pixel, like that, 254 cross 254 or like that. But the problem with that is, when number of pixel of image will increase, the size of image is increased, the time for processing will increase. That will lead to lot of time consumption. So for each epoch sometimes it will take around 10 minutes, 5 minutes, 2 minutes, according to the size of the image too. So in our case we gone with a very small size image, and then only we could able to train our model faster and without losing the any information which leads to less accuracy. So we are getting better accuracy. The reason is that even though we are reducing this image size and we are running our model for 50 epochs faster, better and efficient, we are getting better accuracies. For all the models I can show you the accuracies. And the next part is that this paper speaks about only one model, one CNN model. But whereas in our case, in transfer learning model, we are going multiple. So we are going with around 5 transfer learning models that you can see. VGG, ResNet, VGG16, EfficientNet, DenseNet, and all of them are giving really good answers. So accuracies are very good. This is for transfer learning of ResNet. This is VGG. This is VGG, where validation accuracy is more than 90% and training accuracy is 99.48. And VGG 16 you can see. Again VGG 16 is performing a lot better. Okay, 90.75%, 99.48, and efficient net or efficient net also we are getting around 90% 61, and we'll able to see the dense net. The DenseNet is performing better, and it is giving us around 90% for 90.89% of validation accuracy, and accuracy is 99.25. And also the next gap in this paper is under result and analysis. They are going with only accuracy, only one parameter to define the entire project. But each time whenever you want to compare any models, you need multiple parameters to compare. For example, in our case, we are trying to display multiple parameters like testing accuracy and testing losses, and then we are going to generate a classification report, we are going to generate a confusion matrix. You may heard about these things: accuracy, precision, recall, F1 and kappa scores. So mainly these four we call them as classification report. Among them also F1 score is the main parameter that defines our project, so we need to take care of F1 score also. So we are generating extra features to evaluate our model. We are not restricting ourselves to only loss and accuracy. So for each model you are going to get those things. And graphs, anyway you will be getting the graphs, epoch and accuracy, epoch and loss graphs, you will be getting it. With that, confusion matrix, classification report, which will try to give us how our model is performing after the training. So all of our models are having classification report with the testing and testing loss and testing accuracy. Now we'll come to this paper. Finally, this paper we used as a base paper just for an idea, and over this we implemented our own methodology which is performing a lot better than this paper, and our results are proving it also. Our results are good, and their performance parameters are higher than the existing paper because of the methodologies that we performed over our data set. So now we are going to see the web application that we built by integrating front end and back end, where we can able to see the results. For this entire code build, we used Anaconda software, and for coding we used Python. For front end we used HTML, CSS. For back end we used Flask. So we integrated all of them to build a good looking front end where you can able to upload any image of a skin cancer, and we can able to detect what type of cancer is that. So this is our web application where we integrated our model. You can see details of our models, what all each model is having, and how the accuracies and all the informations that you need related to the skin cancer. So you'll be having entire things. We can provide you all these things with complete front end on all the informations that we discussed now. As a documentation, that documentation you can use it for your reports and PPTs. For our service we charge according to the requirement, what you need and how you need. So we Smart AI Technologies actually provide a service for researchers and students, where we help students to learn things in ML and AI, and will help you to code to understand, you can buy these projects from our website, and you can call to the number given below, or you can just WhatsApp us. So we'll let you know about the next details about your requirement. So now I'm going to click on this use skin cancer. So you need to log in. For that I used MySQL as a database for login and register, and it is not dummy, it is working one. And now you can see, so now we are going to feed few extra new images and we'll check. Okay, so you can take any image, any other image. Example, I'm going to take this. So you are going to get, and you can even download, and you can see the PDF of the report, who is that patient and what are all the details, and then you can come back and upload any new image from the other class. Okay, so you can upload many number of images and check how the results are. You can try from other classes too. Okay, so you can upload any image from any subfolder or any class. You can able to get the proper report generated for that patient. You can even download that as a PDF and you can read those things. So this was our entire project demo. If you want code and the dataset and our support in building this application, or if you want us to help you to implement all these things in your system with support of documentation for your reports, PPTs and mentorships, you can contact us to the given number below. You can just WhatsApp us or call us. Will be able to respond to you with the proper information. So according to that we can move further. Okay, thank you very much for the time, and I think you liked our video. You can just like and subscribe our channel. Thank you very much.